Okay, so at this point, we've gotten pretty far along. We've got all these cool functions, and you might be thinking we have so much capability here, but the one thing we can't do yet is draw a circle. Okay, we made polygons, squares, all sorts of stuff like that, but we can't draw a circle. Okay, and so let me add this comment here real quick. Good habit to get into is adding comments. So the question is, well, how could we draw a circle? And the answer is it's really, really complicated and very, very challenging to draw a circle. It's possible to come pretty close, but the function that we'd have to write would probably be like 20 or 30 lines long. I worked on it in preparation for this, and my initial plan was just to have it linked somewhere where you could copy it, and then you would just paste it in. But there's actually a simpler way. Okay, so instead of doing that, what we can do is, instead of trying to draw a circle, we can draw a 20 or 40 sided polygon, because the more sides a polygon has, the closer it is to looking like a circle, and this will allow us to kind of cheat and make a circle that's not really a circle. Okay, and so here's how we're going to do that. We're going to make a function called, we'll start with left, so arcleft. Okay, and so we're going to have two arguments here. We're going to give a angle and a radius. Okay, and so what this is going to do is it's going to draw an arc that has a radius that you input, and it's going to go a certain number of degrees that you input. Okay, so if you input a 360 degrees with a radius of 10 centimeters or 100 millimeters, then it's going to draw a circle that has a radius of 10 centimeters or a diameter of 20 centimeters. So, or if you put, for angle, if you put like 90 degrees, then it'll draw a quarter circle, things like that. And so this is a useful tool when you want to draw arcs and circles. Okay, and so before we get started, we have to think through this process. Okay, so we want to draw a 40-sided polygon. So draw 40-sided polygon. Okay, but in order to do that, in order to use our draw polygon function, we have to make a decision about we have to input the number of sides and the side length. So I can tell you how many sides it should have, but we have to figure out what the side length should be. And so we're going to have to do some calculations to find this side length. Okay, so find side length. Okay, and then the other problem that we're going to have is we don't necessarily want to draw this entire polygon. Okay, we want to do some fraction of it based on the angle that we're inputting. So we're going to, instead of reusing this function, what we're going to have to do is we're going to have to copy part of it back down into here. Okay, and so this will be a little bit complex, but it should work out pretty nicely. Okay, so the first thing that we need to do is we need to find the side length. Okay, and if we look here, the calculation to find the length of a side is 2 times the radius times the sine of 180 divided by n. Okay, and so we're going to use that here. We'll say float side length equals 2 times radius times, and here we need to use sine, and then it's going to be 180, so sine of 180 over the number of sides, which in this case is going to be 40. Okay, now before we continue, there is something we need to do. So if we look up sine for Arduino, we'll get some more information about how this is going to work. So if we look here at the reference for Arduino, it says that the sine function requires radians. Okay, so if we go back to here, we can see that this is 180, which is half of a circle, and so in radians, a half circle is pi. Okay, which is, we have stored up here at the top under the word pi, and so that should do the trick for us, and that gives us the side length. Okay, and now the next step is to figure out, so if we wanted to, we could just send it straight to the draw polygon function if we were drawing a full circle, but since we're not, since we're doing part of a circle, then what we're going to need to do is we're going to need to basically figure out how many steps around the circle, or how many times we want to go forward and turn for the circle. If we're, let's say if it would be like a 90-degree angle, we would do it only 4 times, or only a quarter of the times, if so 10 times. If it was a 180-degree circle or arc, then we would do it 20 times, so half of the 40 sides. And so that's what we have to figure out. And so we're going to do create an integer. Well, let's go like this. Let's make our for statement first, so we can even copy this right here. So for, copy all this right down to here to draw our 40-sided polygon. Okay, and then what we're going to do is we'll remove this part right here because we know for sure that we want to go left. So it's because it's an arc left. So left, angle. And so from here, what we need to do is we need to assign a value from sides. And if I were to verify this right now, it would give me an error because this value for sides is not defined yet. Okay, it was defined up here, but we haven't defined it in this new function. So we're going to create sides for this function, so the number of sides we want to draw for this polygon. And the way we're going to do this is we're going to use a ratio. Okay, so what ratio of a circle? And so we know that if we take the angle and divide it by 360, that will tell us what fraction of a circle we want to draw. Okay, so if our angle is 360, then we'd put 360 right here. When we divide it by 360, we get 1. Okay, and then we'll multiply that by the number of sides of our polygon, 40-sided polygon. So we'll multiply by 40. And so if we get 360-degree angle, we'll do 40. If it's 720, we'll do 80. If it is 180, we just do 20. If it's 90, we do 10. And so this gives us the number of sides, and we'll step it that many times through. Okay, now the last thing that might be a factor here is you might want to copy in, I haven't tested this extensively, but what you might find as you're doing this is that since you're stopping and turning really quick and stopping and turning really quick, you might need to slow down the motors for this part. And so you could put the set speed at the top of it and at the bottom of it, and you could slow this down maybe to like 2 RPM to 3 RPMs. I haven't tested this out extensively, so you might want to try it out a couple times and see what makes sense for you. And then you could just step it back up to the whatever speed you're using afterwards. And to avoid making mistakes, let's go ahead and do this. Let's make a variable for speed, motor speed. So float motor RPM, and we'll set it, for mine it was at 7.5. For yours it could be something else. And so the reason I want to do this right now is so that if we change it here but don't remember to change it there, we don't want it to suddenly speed up or suddenly slow down. Okay, so we'll go ahead and use this every time we have our regular running speed, so that we make sure we keep it the same all the way through and don't accidentally change it in part but not the other part. Okay, and so you can test out this speed and see how it works, see if it makes sense. And then I'd also, well, let's verify to make sure it works now. looks like I've got a mistake again. And probably missing a semicolon. There you go. Should be good now. Okay, so anyway, as I was saying, the next step would be to build an arcright function. Okay, and so kind of go through that process again to build the function for arcright. It should be pretty similar. Okay, so go ahead and do that now. What I've been doing is I've kind of been going back and adding in comments, but I think it's important to do it as you go. So if you were to come back and look at this function, that you could understand what was going on. So here I'm going to say this calculates the length of a side for a 40-sided polygon given a radius, uses the angle to find what fraction of an arc, or a circle rather, to draw. And then we could say the purpose of this function to draw a 40-sided polygon to approximate a circle. Okay, and so these are things that you can do to help yourself out when you come back later. And one other thing I want to mention, so we talked about changing the speed. This isn't very precise because we're going to have to round here to whole number sides. And so like if you were doing something that didn't go evenly into 40, well, then that could be an issue. So one thing you might want to consider, in addition to slowing down the speed, you could try messing around with this number 40. You could change it to 80, to 180, 360 even, and see how that goes. It might affect the one challenge that could come into play here is if you keep switching back between going forward and turning, it could cause it to kind of shake a little bit or to kind of jolt a little bit. And so all of this stuff, as you do it, tweak it so that you're happy with it. Okay, so hopefully this made sense and hopefully this was helpful.